Okay, guys, let's just jump right in. This episode is going to be kind of long, I think. I'm suspecting that it's going to be pretty long. We've got a lot to do. So if you want to go ahead and grab the popcorn or whatever, or if you're coding along, just get mentally prepared because we are just going to jump right in and get this going. So what we're going to start off with is we need to create the state machine for our character. So if you come to our entities.js file, open that up. Let's go to Jack. And first thing I want to do is I want to get reference to myself by doing this. Okay, and then after that, I need to create a state machine. So I'm going to set his current state, and that's going to be equal to self dot. Let me pull up my notes here. It's going to be equal to states dot standing, which we haven't created yet, but we're going to do that right now. Okay, so underneath animation, let's do this dot states. That is equal to an object. And our character is going to have multiple states. He can either be jumping, he can be standing, or he can be walking. In each of those things, we're going to have two different methods. We're going to have a movement and an animation. So we're just breaking this up. We're making this kind of abstract, and we're just saying, okay, if Mario is jumping, then I need to have a method to call on movement. And I also need to have a method to call on animation. Each of those methods will take in data as a parameter, and then basically we just need to decide what happens on each of those. So let me create the states. Okay, so we have jumping. Mario can be jumping. He can be standing, or he can be walking. Okay, let's handle, we'll just start from the top. Let's handle jumping. Okay, when Mario is jumping, I need to handle the movement of him. So what I'm going to do is I'm going to say if self dot velocity y is equal to 0. So I know that he hasn't jumped yet. Then I'm going to create a jump sound. I'm going to set it equal to the jump sound that we created in a couple episodes back, this guy. So I have access to him. Dot clone node. The reason why I'm doing clone node is it's a special function so that if we press it multiple times in a row before the sound is finished, it will still create a new instance of the sound. So now we have that. I'm going to do jump sound dot play, and I am going to set Mario's velocity y equal to, I'm going to subtract 23 from, so basically it goes from 0 to negative 23, which will force him to jump up. Okay, so that's all we have to do for movement on the jumping state. On animation, we need to check whether or not which direction he's going, and then we need to draw or change the sprite image. So what we can do is we can come in here and I can say if self dot direction is equal to right, then I just need to set our sprite, so self dot sprite equal to sprite animations dot jump right. So I'm just setting it to that sprite. If not, I know he has to be direction left, in which case I'll do self.sprite is equal to self.sprite animations.jump left, just like that. Okay, so now our character, movement wise and animation wise, he will be able to jump. Let's move on down to standing. If he is standing, then there is no movement. So I'm just going to do a return statement. It will get here and it will return and do nothing. If he is standing, we need to change his sprite. Same thing. I'm going to come up here and copy this if else. So I'll copy this. But we need to know, okay, if his direction is right, then instead of jump right, it's going to be stand right. Instead of jump left, stand left. Okay, those were easy. Now, for the last one that's a little bit more complicated, we need to handle walking. Okay, if Mario is walking, we need to know which direction he's going. So we'll do self.direction is equal to right. Oh, why do I keep doing arrays like that? Okay. Then all I'm going to do is self.x is equal to self.velocity x. And we set that speed, so how fast he's moving to the left down here at 3.8. Okay, if not, we know that he is moving to the left. And I'm just going to simply set his x to minus equals self dot velocity x. So he goes opposite direction, just like that. We'll save that. And now for a little bit more of a complicated thing. It's not too much complicated. We need to do the animation. Okay. So I need to check which direction he's facing. If he's facing right, then I need to change his image. Now again, we're gonna do this little trick where we get the animation frame. So data.animation frame, and I'm gonna say every 5 ticks. Then I want to change up the animation frame, so I'll say self.sprite. This is kind of what we did with the coins, if you remember in that previous episode. .sprite animations .walk right .frames, and then self.sprite animations .walk right .current frame. So now we'll be able to rotate through the different frames. Self.sprite animations .walk right .current frame, and we'll increase the frame each tick. Then I just need to check to make sure that we don't go over the amount of current frames. So self.sprite animations .walk right .current frame is greater than 2. Then we need to reset it. So I'm just going to copy this current frames on the walk right and set it equal to 0. So it goes through the cycle. Okay. We need to do the same thing. So this is the if statement. If it's else, it means he is moving left. So what we can do is I'm going to copy this if check and just change it out. So if data animation frame every 5 modulus 5 is equal to 0, so every 5 ticks, self.sprite, we need to change this to left, walk left dot frames is equal to walk left current frame. Okay, then we need to update left and down here as well. Okay, now we have our character ready to move and animate. And you might be asking yourself, okay, that's cool, but how do we essentially get him to get into these states? So that's the beauty of this state machine. We currently have him as standing. What we're going to do is we're going to go over to our input file. And what we're going to do is I'm going to create an update method. Okay, so every single tick, we're going to be checking this method. I'm going to pass in data, and we need to update what is going on. So if we go over to our game.js, don't forget, we need to instantiate or call this update method. Okay, so every single tick, we'll call this update. And what I want to do is I need to check for inputs, so which arrows are being pressed. Okay, I am going to namespace Jack here, so I don't have to type it out every single time, of course. And then I'm going to check for if the left arrow was pressed. Okay, so if, well, actually we're checking if it's down. So if input dot helpers dot is down, this guy right here, what's going on here? Helpers function, oh yeah, okay, so helpers dot is down. If that is equal to 37, which is the key code for the left arrow, so we know that that has been pressed, then I need to also check if if Jack dot velocity y, if it's set to 0, so we know he's on the ground, then I need to change his current state. So this is how easy it is, guys. We know that he has to be walking now. So I just simply set it to jack.states.walking. And guess what? We already have a check in place to see which direction he's walking and whatnot by on our actual module here. If you remember right, we're checking here. So we need to set that. Since this was the left key, I need to make sure that we say, Jack, your direction now is equal to left. Okay. And we also know, okay, this is from this check here, he wasn't jumping. So he must be walking. But if he is, if this isn't 0, then it means he is moving, like he's falling or he's jumping. So all we're gonna do is change jack.x minus equal jack.velocityx. Okay, so this check right here is just seeing if the velocity y is set to 0, then we know he's standing on top of something, so we can make him walk. If it's not, then we know he's either falling or jumping, in which case the user should still be able to move him if he's falling or jumping. So we'll just change and appropriately set the x and y. Okay, so that is a good check. Next, we need to do the right arrow. See if that's being pressed. So I can do kind of the same thing. If input dot helpers dot is down, and the key code is 39 for right. Oh my gosh, it's like my shift key is not working or something. All right, let's copy this, because it's essentially, actually let's copy the entire thing. It's going to be pretty similar, just a couple variables are being changed. So I'll say jack.current state is walking. If not, we are going to add, not subtract, because he's going a different way. And we'll change the direction to right. Perfect. Okay, and the last key that we need to listen for is the up key to tell if he is jumping or not. So we can do if input dot helpers dot is pressed, and I pass in 38. Then we know that the user tried jumping, and notice how we used is pressed. The reason is because I don't want the user to be able to hold down and just keep making Mario jump so high. So, or Jack, sorry. So all we have to do is change his current state to equal Jack.states, and he's going to be in a jumping state. Boom, just like that. Okay, awesome. Last thing we need to do, so now we have input from the user. The last thing we need to do is now handle the animation. So we need to make sure that this call, we call the Mario current state animation every single time. So, or not Mario, Jack. Sorry guys, I'm going off of, I built this originally for Mario, obviously change it up a bit because I don't want to get sued or in trouble or anything, even though this is for education purposes and it's free. I changed it up enough that I think we'll be okay. But what I want to do is data.entities.jack.current state dot animation. So we make that call no matter what state is on, it's going to call the animation state, and all I have to do is come up here and do animation dot jack, pass in data. Okay, the last thing we need to do is for movement. So animations should be fine, but we need to allow our character to move. So let's create a new file. I'm going to call it movement.js. And I'll do var movement is equal to an object here. Let's, before we forget, go into our HTML file, load in that script that we just created. It's a JS file, and it's movement. Save it, go back to that file we just created. Now on movement, we need an update function that's getting called every single tick. And all it's going to be is Mario. So let's do Mario, jeez, Jack, not Mario. And this is going to have data, so we'll have data passed in here as well. And it's going to be data.entities.jack.current state.movement. And again, doesn't matter what state he's in, it has a movement method that's going to be called every single tick, and it's going to handle itself. That is the beauty, folks, of a state machine. We'll call it up here, movement.jack, and pass in data. Okay, let's not forget to go to our main game.js file. It needs to go in here. Of course, the order does matter. It needs to go before physics so that the movement doesn't look like it's off if there's collision or whatnot. So let's do movement dot update, and we'll pass in the data object. Just like that. All right, guys, let's see what damage was done. Let's go ahead and I'm trying to think if there's anything else, but I think we're good. Let's go pull up the site. I guess that's probably the best way to find out, is we can pull it up and see. I'm gonna hit F12 to bring in the browser console. Okay, no error so far. Now I hit the right. Oh, okay. So it is working, but look at that. It's moving by itself. Like, I'm not holding down right now. It's just still trying. It's acting as if it's still down. Okay, So that means, look at that. Okay. So I might have had a little bit of a bug. Something is happening on our input. So let's go take a look. Let's go to input here. Okay. Helpers. Let's make sure that we had this correctly. I had for left and for down, we were just doing input.helpers.isDown. Okay. Let me check. Then the up arrow is pressed. So it's almost like they're not getting deleted out. Let's see. Is down. All I'm doing is returning input.helpers.down with the code. Is pressed. Code. I'm returning false if that code's not in there. Okay, that was working. Yeah, it's something with this init file that wasn't working. Are we calling init on our input? Yes. Okay, if on key down function we pass an event, self.helpers.down event.keycode equals true. I think it's something to do with this. Self.helpers.down the event.keycode. Delete self.helpers.pressed on key up. Let me make sure. Let's see. Event self.down event.keycode is equal to true. Delete self.helpers.down event.keycode. Self.helpers.pressed event keycode. Seems like that should be getting deleted. Okay, we are going to do some debugging, guys. So sorry, it's going to make this episode a little bit longer. Let's go to the console. I'm going to hit Control O in my sources, and I'm going to open up input. That's the file. And press right here. So if I press up now, yep, we pause it. Okay, let me see this object. Okay, 38 is true. Now if I step over that, that should be deleted now. Yes, is true. And on pressed, yes, it was 38. But now if I step over it, it should be empty. Okay, that worked. But it didn't. Oh. We're not resetting his current state. If that's empty, his current state needs to be reset. Okay. That's what's happening is basically we're just keeping Mario's state the same, but he needs somewhere in our code, we need to reset his current state to standing. So we need to check and see oh, that's where it is. Okay, if you remember in that last episode, we removed it. So in our physics here, we commented out here, we said, where was it? It was in here. Yes. We need to reset the, was it in physics? Let me check real quick. It might not have been in physics. I forget where it was that we, oh, it was with collision. Right here. It's right on screen. Everyone, you guys probably watching this like, it's right there. Yeah, it's right here. We need to reset. If he's on top of something, we need to set it to standing. I think that was the error. Okay, let's go back to our browser here. Remove the breakpoint because that was working. Let's go down. Boom. Okay, now look at that. Okay, if I barely tap, that's what happens. If I hold, that's what happens. He's walking into the walls and stopping. And if I press up, that's what happens. Up and over. Perfect. Awesome, guys. So if you see that, we need to add collision detection. So let's see what we need to do. We need to add collision detection to this exit pipe and handle what happens there. And then I think in the next episode, we'll handle the coin detections and add on the score and whatnot of what happens when he lands with a coin. So let's go over real quick to, yes, our physics machine. And if we come up here to collision detection, we need to now do data dot entities dot exit pipe. And we need to do just this collision detection entity collision check entity collision check, and we'll pass in data dot entities dot exit pipe. Okay, so now we get this far, he collides, and now we need to handle it. So let's go to handle collision. We already did a check here for if it's a wall, so we want to do another check here and say if entity dot type is equal to exit pipe, then we need to handle it. So on the exit pipe, what's going on here? On the exit pipe, there's really three things that can happen. He can either run into the right side of the exit pipe, or he can go onto the top of the exit pipe. So let's check for the right side handling. What we'll do is another one of these algorithms. Jack.x is greater than entity dot x, and jack.y is greater than or equal to entity dot y. Then we know that we need to reset Jack's x value and set it equal to the entity dot x plus entity dot w, just like that. Okay, and essentially what that's going to do is it is going to actually hide Mario. So yeah, that's the best I'm going to handle it right now. You could do something else, like, you know, send in like a splash screen like, oh, game over, whatever. But for this tutorial, I'm just going to have him hide. So what this will do is it'll take the X plus the width, and it'll place Mario just right off the screen, so we won't see him. It'll look like he's disappeared or whatever. And the last thing we need to do is top of pipe collision. This is going to be similar to up here, so I'm going to copy this guy just like that, and let me just go over. So jack.y less than entity y, and that plus 10. Current state, reset it to standing. Jack.y is equal to entity.y minus h. Okay, perfect. Let's save that now. And now we are handling the exit pipe collision. And in the next episode, let's save it and check it out. But in the next episode, we are going to handle the coins and what happens when we collide with the coins. And that will be the last episode, guys. And we'll do a coin counter. So at the top, it'll display how many coins he hits. So let's check it out. He's moving, jumps up. Of course, we're not detecting any coins. What if he jumps on top of the pipe? Perfect. Okay, you can't go through it that way. And now, boom, if he goes inside. Okay, that was sort of what we wanted, but it wasn't fully. Let's see here. So let's see. Oh, that's what it's doing. We need to detect collision here as well. Okay, so let's go back into our file here. Last thing, guys. Left side of the pipe collision. And all we need to do is do an if jack.x is less than entity.x and jack.y is greater than or equal to entity.y. Then I need to check if Mario dot velocity y is equal to 0, so he's standing on top of it, he's not falling. Then I need to do Mario dot x plus equal 200. We'll throw him off the screen. Else he is jumping, then we will just, not Mario, for goodness sakes. That's got to be annoying for you guys. I'm sorry. It's getting annoying for me, actually. Jack.x equals entity dot x minus jack.w. Okay, let's save that and give it a go and see if that behaves the way we are expecting. Okay, let's jump over. We can jump on top of the pipe, jump down and through it. Perfect. Now let's make sure that if he's falling, perfect. Awesome. Okay, guys, I will see you guys in the next episode where we will handle the final chapter. It's the last countdown on what happens when we collide with the coins, and we'll add a little coin collector at the top so we can see how many coins our little Jack the Lumberjack's collected. All right, see you there later.